Greetings, math fans. All right, so today's topic is basically a bunch of miscellaneous topics. All has to do with graphing, and the topics are we're going to talk about asymptotes. We don't like to talk about asymptotes. We like to talk about donkey purses because we don't want you guys getting in trouble for swearing. And then we're going to talk about maxes and mins, and also domain and range. Very exciting. Okay, not that exciting, but just still kind of exciting. It's math. Okay. Anyway, let's talk about asymptotes first. Okay, so where do you have an asymptote? What causes an asymptote? Well, you guys should know what causes an asymptote is when something is undefined, when a function is undefined. So that's actually pretty important. So let's write that down. When it's undefined, you have an asymptote. Okay, so you basically have to look at each trig function equation and say, well, based on the trig function, where's it undefined? Okay, so kind of like tangent. Well, where's tangent undefined? Well, it's undefined at, pi over 2, right? Tangent pi over 2 is undefined. 3 pi over 2, negative pi over 2. So those are places where tangent is undefined. What about cotangent? And you remember tangent is undefined at these locations because remember how we set it up? We said negative pi over 2 less than or equal to x less than or equal to pi over 2. And I even said that these guys here are your asymptotes. Okay? So cotangent, right, we set it up between 0 and pi. So we know 0 and pi and 2 pi and 3 pi, etc. Okay, that's undefined there. What about cosecant? Well, cosecant goes with sine. So whenever sine is 0, it's undefined. So it's 0 and pi and 2 pi, that's where sine is 0. And then the last one is secant. Where is secant undefined? Well, it's undefined at cosine of pi over 2 is 0. So pi over 2, 3 pi over 2, 5 pi over 2. You could even go negative, negative pi over 2. Okay? So keep that in mind. That's where everything is undefined, and that's how we're going to find our asymptotes for these different equations. Okay? All right, so let's start out with, literally if I just give you this equation, y equals tangent of x, the most polite of all the trig functions, also used widely by the U.S. Army tanks. If I ask you where's this undefined, we kind of already did this one. You're basically setting this equal to pi over 2. Well, there's no work, so there's the answer. There's an equation. And by the way, don't forget to write x equals. Okay? It's an equation. If I say where's undefined, you say pi over 2, I'm going to be like, that's great, it's a half a pi. What do you want to bake the square and square half a pi? You got to tell me x equals. Otherwise, you don't get full credit for it. Okay? So that's easy, and then of course I can just literally set x equal to 3 pi over 2, x equals negative pi over 2. So again, we kind of did that already. So what happens if I gave you another equation like y is equal to tangent of parentheses 2x plus pi over 4? Okay, well remember it's undefined when this is equal to pi over 2. So let's set it equal to pi over 2. So 2x plus pi over 4 equals pi over 2. Oh yeah, and then you just solve for it. It's pretty easy. So we're going to subtract pi over 4 from both sides. You get 2x equals pi over 4. And then multiply this by 1/2. So x equals pi over 8, which is what happens when you eat a lot of pie. You over 8. Okay, that's an equation of one of those asymptotes for this specific equation. Okay, a lot of times I'm going to ask you for 2 of them. That just means we already know where's tangent undefined. Oh, at pi over 2. Well, where else? Yeah, how about negative pi over 2? So let's do this one over here. So 2x plus pi over 4 is equal to negative pi over 2. I could have also done 3 pi over 2. Doesn't matter. Okay, it's your choice what you want to do. There's an infinite number of asymptotes. So we're going to subtract pi over 4. So we get 2x is equal to negative 3 pi over 4. And then multiply this by 1/2. So x is equal to negative 3 pi over 8. Okay, that's another one of your asymptotes. So pretty easy, right? Okay, so let's look at another trig function. But again, it's kind of the same thing. We already went over where everything's undefined, and literally you just set that part equal to where it's undefined, and you come up with an asymptote. Pretty easy. So let's try a couple more. Okay, so let's try y is equal to 3 minus 17,582 cosecant of 2x minus pi over 4. All right, right away I can see your eyes looking at going, Mr. Curves, what are you doing? It's brutal. 17,582. Guys, when I'm trying to find the asymptotes, this doesn't matter. This stuff right here doesn't matter. Okay, that 3 is your vertical shift. This is your value of A. That's how high and low your sine graph, your amplitude of your sine graph. So it doesn't matter. Not when we're trying to find asymptotes. This is the only thing that really matters. Okay, so where is cosecant equal to, or where's it undefined? Well, it's where sine is equal to 0. And of course we know sine of 0 equals 0. So I can set this guy equal to 0. So 2x minus pi over 4 equals 0. And then you just solve. Okay? So 2x equals pi over 4 and multiplied by 1/2. So x is pi over 8. That's an asymptote for that one. Okay? Pretty easy. Get that equal to pi. So I can do 2x minus pi over 4 equals pi. Again, add pi over 4, so I get 2x equals 5 pi over 4. And then multiply by 1/2. So x is 5 pi over 8. Okay? All right. Pretty easy. Pretty easy. Okay? Let's try another one here. Okay, how about y is equal to 2 plus 7 cotangent of 2 parentheses x minus pi over 4. Okay, again, where's cotangent undefined? Well, we know, again, setting it between 0 and pi when we graphed it, okay, so we know it's undefined at 0. So again, I don't really care about this. It doesn't matter to me. This is what I'm setting equal to, in this case, 0. So 2x minus pi over 4 equals 0. So divide by 2, which just gives me x minus pi over 4 equals 0, or x equals, add pi over 4, so I get x equals pi over 4. Okay? You know, again, I'll do another one because I'm usually going to ask you for 2. So 2 parentheses x minus pi over 4. There's another one at pi. Okay? So divide both sides by 2. So x minus pi over 2, or pi over 4, sorry, equals pi over 2. And then I add pi over 4. So x equals 3 pi over 4. That's another asymptote. Okay? Pretty easy. Pretty easy. Okay? Let's do one more asymptote one. Let's do y equals 7 minus 6 cosine parentheses 2x minus pi over 7. Ooh, that's not too friendly. Okay? Okay, so now where's my asymptote for this one? All right, where is it? So think about it. I know it's a video here, so I'm going to let you think a little bit. Where's the asymptote for this one? Okay, I'm not going to do the whole thing. Anyway, here's the deal, math fans. It's cosine. There is no asymptote. No asymptote. Okay? You know, I mean, you guys should know a normal cosine graph looks like this, right? There's no asymptote. It just keeps going. It has no asymptote because it's not undefined anyplace. Secant is undefined. Cosecant is undefined. Tangent and cotangent. But cosine and sine are never undefined. So there is no asymptote for a cosine or sine graph. Okay? So make sure you know that. Very, very important. No asymptote. All right, cool. All right, let's talk about maxes and mins now. So a max and a min. So when I talk about max and min, I'm really talking about y values. So basically, max is how high it goes, and minimum value is how low it goes. That's easy. Okay? So you're only going to really, the only kind of problems I'm going to give you with maxes and mins are sines and cosine problems. So let's just start out with a nice little friendly problem here. Aren't they all friendly? Okay. 2 plus 3 sine of x. So just like before, how we didn't care about the 2 plus 3, that's the only thing we care about now. I don't care about this. This could be sine of 2 parentheses x plus pi over a billion. That doesn't really matter. Okay? It's the 2 and the 3 that actually matter. So think logically. So let's just draw one graph here real quickly. Okay, do you guys agree that this is our vertical shift? So we go up 1, 2, and we draw a vertical shift, and that's 2. And then 3 is our amplitude from that vertical shift. So if this is 2, that means I'm going to go up 1, 2, 3 up higher. So 2, 3, 4, 5, and down 3. So 2, 1, 0, negative 1. Right? So it's going to go as high as 5 and as low as negative 1. And that's our max and min. What? Okay, so max is 5 and min is negative 1. Okay, it's that easy. I mean, truly, if I would sketch this, what it would look like is, you know, without even drawing your x or coordinates here, it's basically going to go up like that, as high as that, down to there, and like that. Okay, so what you do is, again, you look at the 2, that's kind of your starting point, and you're going to go, you can go down 3 or up 3 from that 2. So if I go down 3, it's basically 2 minus 3, which is negative 1. And if I go up 3, it's 2 plus 3, which is 5. Okay? And so it's really easy. Just subtract, adding and subtracting. That's all you're doing, math fans. Okay? Really not bad at all. So just to kind of give you an idea, just kind of we can combine a couple things here. We're going to also talk about domain and range. So let's actually just do that right here. Domain and range. Well, for sine and cosine, do you guys agree that the domain just keeps going? So here's a sine graph. Sine graph would keep going the other way too. Okay, so the domain for all these, for the sine and cosine graph, is from negative infinity to positive infinity. Okay, the range is basically from the minimum point to the maximum point. So in this case here, the range is going to be from, and we're going to use brackets because you're actually touching those points. It's going to be from negative 1 to 5. Okay, so that is kind of how domain and range kind of fit with max and min, because it's really your range. Okay, all right, so let's try another problem with cosine. Oh yeah. Okay, so y is equal to 17 minus 63 cosine of 2 parentheses x minus pi over 83. Ugh, pi over 83, what? Remember what I told you, this only matters, okay, when we're doing the asymptotes. This is what we're concerned about. All right, so we don't even bother with that. No, it's cosine. So let's talk about max and min. First of all, do you guys agree the maximum, you're going to start at 17 and you're going to go up 63. Some of you might be saying, wait a second, Mr. Curtis, it's minus 63 though. Yeah, that's true. So it's going to go down first, or it's going to start at the low point, but it'll eventually go up 63 from that 17 and down from down 63 from the 17. Okay, so basically 17 plus 63, that's going to give us 80. So that's our max. And our min, we're going to start at 17 and subtract 63. Okay, and that's going to give us negative, so 17 minus 63 is negative 46. Okay, so that's our max and min, which then helps us when we do our domain. Well, domain is actually easy, right? Domain is always negative infinity to positive infinity. And the range is, of course, bracket negative 46 to 80. And that's it. Pretty easy, right? Not bad at all. Not bad at all. Okay, let's keep going here. Let's talk about domain and range of some other trig functions now. So again, this is domain and range. So we're really not going to talk about max and min. Max and min is really only when we talk about sine and cosine. Okay. So we know that all the trig functions are periodic, right? They keep repeating themselves, repeating. So we can say all trig functions have a domain between negative infinity and positive infinity. All right, but there's an issue. It's not truly from negative infinity to positive infinity. What do you have every once in a while on trig functions of secant, cosecant, tangent, cotangent. You have asymptotes, right? Okay? So when you have asymptotes, that's just a restriction. It just alters this just a little bit. All right? So, like, for example, if I said y equals cotangent of x, you guys agree it's undefined at 0 and pi and 2 pi and 3 pi, right? It's undefined at that location. So I can say my domain is negative infinity to positive infinity, except, so I'm going to say x is not equal to n pi. And you're going to tell me n is an integer. That just means it's a set of integers. So this is really the notation. You guys already know this, okay? But this is saying x is not equal to n pi, and n is an integer, so that means that 0 pi, 1 pi, 2 pi, 3 pi, and here it is, 0 pi, 1 pi, 2 pi, 3 pi. It could be negative, but n is an integer. You need to tell me that, because if you just say x is not equal to n pi, that's going to be, then you're going to say, well, what's n? N can be any number. No, it can't. It's got to be an integer. Okay? All right, so that is the domain for y equals cotangent of x. Let's take a look at y equals cosecant of x. Well, that goes with sine, and sine's undefined at 0, and pi, 2 pi, and 3 pi. So guess what? Woo! Cosecant is the exact same thing. It's got the domain negative infinity, positive infinity, but it can't be equal to n pi. Okay? So that is for cotangent and cosecant. So let's talk about tangent now. So think about it. Y is equal to tangent of x. So again, the domain is from negative infinity to positive infinity. But now, remember the asymptotes were x equals negative pi over 2, and pi over 2, and 3 pi over 2, and 5 pi over 2. So the way you write that, it's a little tricky how you write it, because it's definitely every pi, but it's got to be at the pi over 2 mark. And this is what a lot of people want to do. They want to say the domain again is this, and they want to say, but x is not equal to, and they like to say n pi over 2. And this is actually, so not equal to. This is actually wrong, and the reason it's wrong is because when n is 1, that's great, it's pi over 2, but when n is 2, it's 2 over 2, which is 1, which is pi, and that's not true. All right, so the way you write this is x is not equal to n pi plus pi over 2. Okay, that takes care of it. So now when n is 0, that's 0 plus pi over 2 is pi over 2. When n is 1, it's pi plus pi over 2, or 3 pi over 2. When n is 2, it's 2 pi plus pi over 2 is 5 pi over 2. So you can see we hit all the values. So it's the domain is negative infinity to positive infinity. X is not equal to n pi plus pi over 2, and again, n is an integer. Okay, that's how you write, that's the notation for y equals tangent of x. And of course, what else is undefined at pi over 2 and 3 pi over 2? You should know. Well, what is 0 at pi over 2? Well, isn't cosine? So that means it's secant of x. That is also the same domain as tangent. Okay? Pretty mellow, pretty mellow. So that's talking about domain. Okay? Let's talk about range for a little bit here. Okay, let's talk about the two easy ones. If I graph y equals tangent of x, okay, do you guys agree that the graph looks like this? Negative pi over 2, pi over 2. Then I have asymptotes here. The graph looks like this. So think, what is the range for this problem? Okay, well, of course, you're going to positive infinity and you're going to negative infinity. Oh yeah, so negative infinity to positive infinity. That's the range. In fact, if I did cotangent is almost the same thing, except it's 0 to pi, with the asymptotes here, and cotangent looks like this. That's the same thing. So the range for cotangent and tangent, let's write this out here, y equals cotangent of x, is they're both between negative pi or negative infinity and positive infinity. Okay? So range is easy for tangent and cotangent. Super easy. It's a little tricky for secant and cosecant. So let's take a look at that. Okay, so if I said y equals cosecant of x. Do you guys agree that the graph looks like this? First we draw a sine graph. So this one's a basic graph. And I'm not even going to label this, but I'm just going to draw the dotted line here for sine. You should put a couple of marks in here and then back up again. Sorry, it's a little messy. Okay, so this is kind of what this is a nice little sine graph. Now understand that now you're going to draw your asymptote. So let's just do this in a different color here. So here's an asymptote here, here's an asymptote here, and here's an asymptote here. Okay, so now when I graph it, this is what the graph looks like. Like that, and like that. So we already talked about the domain. Well, what do you think the range is? Well, understand that, like, for this, if I actually did y equals sine of x, do you guys agree that the range would be from -1 to 1? Okay, here's your low point, and here's your high point, from -1 to 1. So cosecant can't be in between those. In fact, do you agree that cosecant goes all the way to -infinity up to -1? So from -infinity to -1 union, well, nothing in the middle here, but then it starts right here. So it starts at 1 and it goes to infinity. So truly what you're doing is you're using a sine graph to draw your cosine or cosecant graph, right? And then that's going to help you with your range as well. Okay? So it's missing between -1 and 1 because that's where the sine graph is, and the cosecant graph is below that and above that. Okay? It's pretty easy. It really is. So you need to you're almost finding your max and your min for a sine or a cosine graph, and that's going to help you with your secant and cosecant graph. Okay? Because you're going to know, well, the max, well, it's got to be above the max. So let me write that down here. For the cosecant and also secant, it's got to be above the max and below the min. That's pretty easy. Okay, so let's do a couple of crazy problems here. Not too crazy, but let's try a couple of them here. Okay, so y equals 3 plus 2 secant of x. Okay, so again, we just need to find our max and min, pretending this is a cosine graph, right? So our max is 3 plus 2, which is 5. So it's going to be above 5. And our min is 3 minus 2, which is 1. So it's going to be below the 1. So it means our range for this problem is going to be from -infinity to 1, union 5 to infinity. Pretty easy, right? Not bad at all. Again, you're just getting your max and min. So let's do one last one over here. Y is equal to -7 minus 6 cosecant of parentheses 2x plus pi over 3. Remember, this doesn't mean anything at all when we're talking about range. It does when you're talking about asymptote, but not about range, because it's just high and low. So again, we're looking at a sine graph, which again, no big deal, but it's you're starting out at -7 and you're going down 6 and up 6 from there. So -7 minus 6 is -13. And that's our min. And -7 plus 6 is -1, and that's our max. So it's below this, below that, and above that. So for this problem, let me just kind of put a line here. The range is going to be from -infinity to -13, bracket, union, -1 to infinity. And that's it. Okay? So that is kind of an idea of, at least we covered asymptotes. we covered domain and range, and we covered maxes and mins. And those are the level of difficulty problem that you're going to have. So nothing necessarily more difficult, like, you know, you're not going to have some crazy problems for that I didn't show you in these examples. Okay, so everything's going to be pretty straightforward, and you should be good to go. All right, that's it, my fans. Have an outstanding day. Adios. Goodbye.